Chapter 5, we're going to start probability. And probability, again, can be tough, but also sometimes students really understand probability. So you can go one way or the other with probability. All right, probability, again, most of the world runs on probability. All right, we do a lot of things, statistics, actuarial science, again, polling, and all types of things like that are run on probability. And so we're going to hit on probability here in this section. We're going to look at the basics of probability. Probability is the likelihood an event will occur, right? So it's the chance something will happen. When you say, this is the likelihood this will happen, this was the chance that it'll happen, it can be expressed three different ways. When we just say probability, we write it as the decimal or the fraction. When we describe probabilities, we typically describe probabilities as percents, right? When we're talking about it in terms of, I have a 85% chance of it going to rain today, right? That's the percent chance that it's going to rain today, right? We usually describe it. The probability would be 0.8 or the fraction 4/5 of a chance. You should be able to write it each way. Again, luckily your calculator will be able to find the decimal. You usually have a fraction key in the calculator, and then the percent, it's a simple multiply by the decimal by 100% to get your percent. Alright, probabilities always land between 0 and 1. So if you have a negative probability you've done something wrong, you cannot have a negative probability. The lowest probability is 0. 0% chance is that it will not happen, right? Up to 1. 1 means it's guaranteed, right? There is a 100% chance you're going to have a quiz over this material. Alright, 100%, 1. The equivalency is 1. Probability of 1 is the same as saying 100%. And then everything else lands in between, right? So that you have every fraction, decimal, or percent between 0 and 1, or 0 and 100, right? 0 is the lowest, 1 is the biggest. So if you ever get a probability bigger than 1, or bigger than 100%, it's impossible. So when people say, things like, oh, I worked 120% on this, well, that's impossible. You can't work 100%. You can only work up to 100%, all right? So make sure you're aware of that. No negative probabilities and no probabilities over 1. No probabilities over 100%. When we express probability of an event, all of our applications and examples will be equally likely outcomes. It gets more complicated if they're not equally likely. And the probability of an event, when we say an event, is when something happens. What we're looking for, we consider that the favorable event, the number of and so we have to count things, right? We have to figure out how many outcomes are there in the event that I'm looking for, out of how many outcomes were there possible, all right? And so that's how we find probability. So it's always the number of favorable outcomes, the number of outcomes in the event I'm interested in, divided by the total number of equally likely outcomes. So probability of favorable outcomes divided by the total number of outcomes. All right, that's the simple expression. And the hard part about it is counting, which is why, look at how many favorable outcomes and how many total outcomes. But if you see this, you can never have greater than 1, right? Favorable outcomes have to land within the total number of outcomes. Technically, favorable outcomes could include everybody. That would be the 100% chance it's going to happen, right? Or nobody, which would be the 0% chance it's going to happen. We're going to do two simple examples right now, and then we'll get to a more complex one later. The simplest way to sort of understand probability is when you flip a coin, right? If I flip a coin, there's two ways it can land. It can land heads, all right, the Lincoln side, or tails, all right? And so the tails would be the building side. And so those are my two outcomes, all right? So those would be my two outcomes. So when we flip a fair coin, meaning it's not a double-headed coin, it's not weighted in one way or the other. And so the total number of outcomes, so if I go back here to my equation, is 2, right? There are only two things that can happen. All right. So if I want to know the probability, I will flip heads. Well, probability I get heads is the number of favorable outcomes out of the total. Well, there's only one way to get heads, right? Out of the two outcomes, heads And that's what we consider tails. And so there's one outcome out of 2. And so the probability of flipping heads, and most of us know this, right? The probability of flipping heads is 50%, right? That's the fraction, 1 out of 2. The decimal would be 0.5. All right, those mean the same thing. There's a 1 out of 2 chance, and then the percent would be, you would take your probability times 100%. So you take your 0.5 times 100%, and you get out 50%. So that's how we convert to percent. And so those are the 3 ways that probability can be written, right? If we say probability as a decimal, it's the 0.5. If we say probability as a fraction, it's 1/2. If we, again, usually we describe it using the percent, right? There's a 50% chance that I will flip heads. A 1 in 2 outcome, or 0.5 is my probability. All right, the second example I'm going to look at in this set of notes right now is again, we typically do flipping coins, rolling dice, picking from a deck of cards, and things like that. Picking people out of a group and things like that are typical basic probability types. All right, so the next one, if we roll a standard fair dice. So if you've ever played a game, all right, and if you haven't, dice will have 6 sides on it, and each side has dots. All right, 1, 2, 3, 4, 5, up to 6. Right, the dots is how many, the number, what you've rolled. Right, you roll the dot with 1. That's 1. And so I'm just describing it because in the website homework it says how many dots are up there. So the dots represent. So this would be rolling a 1. This would be rolling a 2, a 3, a 4, a 5, or a 6 on my dice. So there are 6 total outcomes. When we roll a fair dice means you have the 6 numbers, regular 6 numbers, and it's weighted fairly, meaning every side is equally likely to pop up as any other side. So that's what we mean by equally likely. It's not weighted funny, so that 2s and 1s show up more often. All right, so there are 6 total outcomes. All right, when you roll a dice, one of those 6 outcomes will pop up. You don't know which one, all right, but there's a likelihood one of them will show up. So again, there are 6 possibilities when you roll a dice, and so out of the total outcomes, so total outcomes is 6. What's the probability of rolling a 6? Well, 6 is that last outcome here, right? The probability of rolling a 6, well, there's just 1 out of 6 chances. Well, that would be if you did that as a decimal, I'm going to round 2 decimal places, or 3, 1.67, or as a percent, 16.7% chance of rolling a 6 with a fair dice. Rolling a 4, well, as it turns out, there's only 1 4, right? So it's the same probability. There's 1 4 out of 6 that you could possibly roll, right? Only 1 chance out of 6. Well, so it's the same probability as... So any of them, if I had to pick 2, 3, 5, there's 1 chance out of 6 of rolling any of those numbers. Which comes out to be a 16.7% chance of rolling any number. All right, then the next example is, well, suppose I have this is my event, right? The event is rolling an even number, so probability that I get an even number, well, how many even numbers are there? Well, there I can roll a 2, a 4, or a 6, right? Probability of rolling my even numbers are my 2, my 4, and my 6. So now I've got more than one chance, right? If I just want an even number, there are 3 outcomes that are favorable out of the total 6 possible outcomes. And so rolling an even number, well, 3 out of 6. Whenever we write these as decimals and fractions, we always write the simplified form. So we don't leave it 3 out of 6. All right, the answer is 1/2. That reduces to always write reduced fractions. Your calculator will do that. Right, you use your fraction key on your calculator. It will take 3/6 and reduce it to 1/2. The decimal would be 0.5, and then the percent would be 50% chance. So you have a 50% chance of rolling an even number. You can roll 3 chances, right? A 2, a 4, or 6, out of all possible answers. All right, probability of rolling a number less than 2. And so what you have to be careful here is 2 is not included. It's less than 2, right? The number less than 2. Well, there's only the number 1. The number 1 is the only number less than 2, right? If it said less than or equal to 2, you would include the 2, but you don't. And so we're just looking for what's the probability that you rolled 1. Well, there's only a 1 in 6 chance. So it'd be the same as these. 1 in 6 chance, 0.167, or 16.7%. All right, so we'll roll the number less than 1. So make sure you're careful. If it had said less than or equal to, you'd say 2 and 1, so there would be 2 out of 6. But it didn't say equal to, it just said less than 2. So there's just the 1 that we're looking for. So what's the probability of rolling a 1? 1 is the only number less than 2 in this case. All right, stop there, and I'm going to pick up the next examples in the next set of notes.